Hello dear students, I hope you are enjoying my online classes and as you know that term 1 is approaching and we are doing the revision for chapter 8 and 9 which is your syllabus for term 1 examination. So we have covered the derivations, we have revised them, we have also covered the NCERT problems and the exercise questions, and now we are taking the session in which students are asking the questions and we are solving it for the entire class. So here I am present with the numericals being asked by students of your class. Have a look and try to understand these numericals. The first numerical is an object accelerates with alpha acceleration for t1 time starting from rest and then retards with beta retardation for time t2 to again come on rest. Show that maximum velocity achieved is given by Vm is equal to alpha bt divided by alpha plus beta. So we'll proceed for the solution like this. We know that if we draw the velocity time graph of the particle and if it is accelerating for t1 time with alpha acceleration, then the maximum velocity achieved by object, let it be Vm, and alpha is the acceleration, then it retards with beta retardation for time t2 and it again comes to rest at zero velocity, and the total time is t, that is t1 plus t2. So that is the velocity time graph. It is for your reference. It is not mandatory to draw this graph for solving this question. So we know that v is equal to u plus at. So starting from rest, v max is equal to 0 plus alpha t1. So this is our first equation, that v max is equal to alpha t1, equation number 1. Now if I can find the value of t1 in terms of alpha, beta and t, then I can find the value of v maximum in terms of alpha, beta and t. So value of t1 is required. Now the concept here is whatever the value of velocity object is achieving by alpha acceleration in t1 time, with beta retardation in t2 time, object is also decreasing its velocity by the same amount because the object started from 0 and the object is again coming on rest on 0. तो जितने मतलब अगर हम बात करें फर्स्ट इक्वेशन ऑफ मोशन से, तो vm की वैल्यू अगर अल्फा t1 है तो बीटा t1 जो है वो भी आपका vm ही होगा, क्योंकि जितनी वेलोसिटी इंक्रीज हुई है उतनी ही वेलोसिटी डिक्रीज भी होगी. तो आई कैन राइट हियर that Vm is equal to magnitude alpha t1 which is also equal to beta t2. So from this equation I can write the value of alpha t1 as beta, and as I know that my t1 plus t2 is equal to t1 plus t2 is equal to t, so I can write my t2 as t minus t1. So if I will place the value of t2, t minus t1, I can write it like alpha t1 beta t minus beta t1. I want to find the value of t1 in terms of alpha, beta and t, so I will try to put all my t1 on left hand side and all other things on right hand side. So bringing this beta t1 on left hand side, its sign will change and it will become beta t1 is equal to beta t. Taking t1 common, alpha plus beta is equal to beta t. So the value of t1 is beta t divided by alpha plus beta. Let us say this is our equation 2. Now putting the value of t1 beta t by alpha plus b from equation 2 into equation 1, I will get v max is equal to alpha into t1, and value of t1 is beta t divided by alpha plus beta, which is the required relation which is to be proved, that v maximum is equal to alpha beta t divided by alpha plus beta. So I hope this concept is clear to you. The concept is alpha t1 is equal to beta t2. That is the concept of this numerical. Let us move on to the next numerical. So the statement of second numerical is car A starts from rest with acceleration 0.2 meter per second square, and after 1 minute car B starts from rest from the same point. Calculate the time after which distance between car A and B is thrice the initial distance when car B started. So let me explain to you what is the problem. So car A started from a point, let us say this point is O, and in 1 minute car A will reach up to this point, and after 1 minute car B starts from this point, and we are interested in calculating the time after which the distance between car and A and B will be thrice the distance which is right now at the starting of the car. So let us first calculate what is this distance which is between car A and B when car B just started. We know that car A is starting from rest, so U is equal to 0, A is equal to 0.2 meter per second square, and T is equal to 1 minute. So we know that S is equal to UT plus half AT square. So S is equal to 0 into T, 1 minute is 60 seconds, plus half into 0.2 meter per second square into T square is 3600, that is square of 60. So solving this you will get 360 meters. So it means the initial distance between car A and B is 360 meters. Now according to question we are interested in calculating a time when your car B and car A are at a distance which is thrice the initial distance. So that is 360 into 3, 0, 3 6 ja 18, carry 1, 3 3 ja 9 and 1 10, 1080 meter. So we need to calculate the time after which distance between car B and A will be 1080 meters, which is 3 times the initial distance. And the distance from their initial positions is 360 meter, we already know. Let us say this is achieved after x distance. So we are imagining it that let us say after x distance, when car is at x distance further from the starting point, car B is at x distance from the starting point. So car B has covered a distance of 360 plus x meters, while car A has covered the distance x plus 1080 meters in same time. Then we can achieve this situation when the separation between them is 3 times the separation comparing to initial value. तो एक बार मैं फिर से बता दूं आपको कि 1 मिनट में जो कार A है उसने 360 मीटर डिस्टेंस कवर किया. अब हम चाहते हैं कि कितने टाइम बाद A और B के बीच में डिस्टेंस इस इनिशियल डिस्टेंस का, जब B स्टार्ट करती है 0 से तो वो इनिशियल डिस्टेंस है, इसका 3 टाइम्स हो जाए. तो 360 हमने कैलकुलेट किया S इज इक्वल टू UT प्लस हाफ AT स्क्वायर से, और 360 का 3 टाइम हुआ हमारे पास 180. ओके, तो हमने ये कंसीडर किया कि लेट अस से x डिस्टेंस बाद और t टाइम बाद, t टाइम भी ले लेते हैं हम आफ्टर x डिस्टेंस, एंड t टाइम जो कार B है और कार A है उनके बीच में जो डिस्टेंस है वो इनिशियल डिस्टेंस का थ्राइस हो जाएगा. और ऐसा करने के लिए कार B को कितना डिस्टेंस ट्रैवल करना पड़ेगा 360 प्लस x, और कार A जिसने यहाँ से स्टार्ट किया था आफ्टर 1 मिनट तो उसको कितना डिस्टेंस ट्रैवल करना पड़ेगा x प्लस 1080. तो ये कंसेप्ट समझने के बाद विच इज द मेन कंसेप्ट फॉर दिस न्यूमेरिकल, हम अप्लाई कर सकते हैं हमारी इक्वेशन s इज इक्वल टू UT प्लस हाफ AT स्क्वायर दोनों कार्स पे, B पे भी और A पे भी. लेट अस अप्लाई s इज इक्वल टू UT प्लस हाफ AT स्क्वायर ऑन कार B. So for car B, if I will apply, then my distance is 360 plus x, which is covered by car B because car B was here. So S is equal to UT, U is 0 for car B, so UT will become 0 plus half A 0.2 and T square. let us say this is my equation number 1, and when I will apply the same equation for car A, the distance covered by car A is going to be 1080 plus x, and the initial velocity of car at this point is not 0 anymore because car A already moved for 1 minute, and I can find the initial velocity of car A by the relation v is equal to u plus at. So velocity of car A after 1 minute is 0 plus 0.2 into 60. So because acceleration is 0.2 per meter square and time is 60 seconds 1 minute, so value of v is 12 meter per second. 0.2 into 60 is 12 meter per second. So that is my initial velocity of car A after 1 minute if I am applying its equation of motion. So 1080 plus x is ut, that is 12t plus half at square, that is plus half. Acceleration will remain same, 0.2 into t square, that is my equation number 2. So if you are able to write these two equations, your numerical is solved. There is nothing much left in this numerical after this. From equation 1, half 0.2 t square, and in equation 2 we are also having half 0.2 t square. So I can directly place the value 360 plus x in equation 2. So my equation 2 will become 1080 plus x is equal to 12t plus 360 plus x. Without making numerical any complicated, x and x is cancelled. We are not interested in the value of x, we need to calculate the time t. So my 12t value will become 1080 minus 360. So 12t is equal to 720, subtracting 360 from 180, and my t is equal to 720 divided by 12, that is 60 seconds or 1 minute. So this is the time after B started. So if the question if examiner asks what is the time after A started moving, distance will be thrice, then your answer is going to be 2 minutes because A has already moved for 1 minute. And if they are asking after how much time of starting of B, the distance between them is thrice comparing to the distance between them after 1 minute, then your answer is 1 minute. And after calculating t, if you will put the value of t in equation number 1, you can also calculate the value of x if it is asked in some question. It was not asked in this question, but you can always calculate it, might be in some other numerical. So 0.1 into t square, that is 3600, so which is giving me 360 plus x is equal to 360. So value of x in this case is coming 0. So it means x shrinks to 0, no problem. Our question will remain same. In 1 minute, the car B covers the distance 360, car A covers the distance 360, and in next 1 minute, car A covers the distance 1080, and car B covers the distance again in 1 minute, which is equal to again 360 because it is also starting from the rest. So it is clear, and if still you are having any doubt, you can again ask me and I can discuss with you. Let us move to the third case which students were asking, and that was about your momentum conservation. So momentum conservation is very important for calculating the recoil velocity of gun. So some students had doubt in calculating recoil velocity of gun. That is topic 3 for today's video lecture. So let me first explain you again what is linear momentum conservation or simply momentum conservation. According to momentum conservation, if a system is having acceleration p1, say initial acceleration, it may have any value, initial momentum p1, and there is no external force is 0, then we know that by Newton's second law of motion, F is equal to P2 minus P1 divided by time taken. And if your F is equal to 0, P2 minus P1 divided by time, and when time will go in multiplication with the force, P2 minus P1 will become 0, or we can say P1 is equal to P2. So your momentum will remain same. The momentum remains same if no external force is there, if zero external force is there. This is known as momentum conservation. So if you are having your bullet of mass small m plus your gun of mass capital M, both are at rest, so their momentum is 0. So our initial momentum P1 is 0. That is our first point. Now what is happening when we are firing the bullet? When we are firing the bullet is achieving velocity v. So momentum of bullet will become mv plus mass of gun is m, and let us say recoil velocity of gun is u. So momentum of gun will become mu, because we know that formula of momentum is mass into velocity. So mass momentum of bullet plus momentum of gun is equal to final momentum p2. Let us say equation number 2, equation number 1. And by the concept of momentum conservation, we know that if external force is 0, P1 is equal to P2. So here also when we are firing a gun, external force is 0, because bullet is moving out with the internal force, because dynamite is attached to the bullet itself. The explosion takes place inside the gun. The force is internal, no external force. So your P1 must be equal to P2, which means MV plus mu must be equal to 0. So mu is equal to minus mv, and u is equal to minus mv divided by m. The negative sign is indicating that gun will recoil in a direction which is opposite to the direction of bullet, that is v. And we just have discussed this question while discussing solution for your CT5, that greater the mass of the gun, lesser the recoil velocity of gun. Greater the mass of gun, lesser the velocity of recoil of gun. क्योंकि गन का मास ज़्यादा होता है, इसलिए गन की recoil velocity कम होती है. ठीक है, तो I hope these numericals are clear to you. It was just an example. We can do many more numericals, but the main thing is practice. If you will practice, then you can solve numericals quickly and correctly within the time given to you. If you will take more than required time, then it will be of no use. With all my best wishes, all the best for your Terminal 1 exam. Like always, thanks for watching and take very well care of yourself. See you in next lecture. Bye bye.